Welcome to Chemistry Lab. Today I will be helping you and giving you some tips about Lab 504, which deals with titration. So first recommendation is to be very patient, because if you are not patient, you can get inaccurate results. The purpose of this experiment is to find the concentration of acetic acid in the form of mass percent, which is usually about 5%. So the way you will do this is by first standardizing NaOH against KHP using titration, and then the second part is titrating the standardized NaOH solution with acetic acid, which I will explain more later. Before we begin the lab, I would like to tell you about some definitions. Titration is a process that measures the volume of a standard solution that completely reacts with a measured sample of the solute being analyzed. Here we have a picture of how the setup of your materials will look. Our standard solution, which is our titrant, NaOH, is just a solution that we know the concentration of. We have it reacting to KHP as well as vinegar solution. So the first part involves standardizing NaOH, which is when NaOH completely reacts with KHP. Therefore, when that is complete, when the titration is complete, it is known as your equivalence point. And this is found through a color change. So materials that we will use for this experiment are the following. Phenolphthalein, which serves as an indicator. It is colorless in acidic solution and pink in basic solution. You need Erlenmeyer flasks for your KHP and your vinegar samples. You need a burette with the ring stand. You need your vinegar solution and as well as NaOH pellets to make your solution. You need a discarded rinse container and a volumetric pipette for the acid component. Make sure to rinse and cleanse with your vinegar solution. Alright, so the proper steps that you should take are the following. The first thing you have to do is to make sure that your burette is clean. A burette measures precise measurements. That's why it is important that it is clean and that you rinse it with the solution that you will use it. In this case, NaOH solution. So whenever you have to clean it, as stated in your manual, you have to make sure that you flip it back and forth and rinse it well. When you're beginning to do the titration, make sure that you go like intervals 1 to 2 milliliter. Notice that when the titrant inside the burette touches the KHP, it turns a faint color and fades away quickly. Make sure that you mix the Erlenmeyer flask well. And how do I know when to stop? When is the titration complete? The titration will be complete when the solution turns slightly pink. Therefore, you have to be very careful and go drop by drop whenever the color remains longer. For example, look at this. It remains for a longer time, especially when you swirl it. That means we're getting closer. Whenever it turns slightly pink, it means that it has turned basic. It's helpful if you put a piece of white paper under it. That way you can see the color change better. For example, look at that. We are getting really close to the end point. So recall, when we added our indicator solution to our KHP solution, it was clear. Now, this is not good. This is what happens when you go overshot or go past the end point. This is what you actually want. A slight, faint, pink color. Once you got your wonderful titrated solution, make sure that you read the final volume. Now with all these information that you have, you can find the volume of the titrant, which is the final volume minus the initial volume. Now also, going along with continuing with our procedures, we still need to do titrate vinegar solution. Now we have vinegar solution reacting with NaOH solution as well. Instead of using your KHP solution, you will use vinegar solution. Therefore, titrate using the burette. The same process. Therefore, like I mentioned before, you have everything you need. You will just do a little bit of stoichiometry to find the molarity of NaOH, which will help you with calculations for your molarity of your acetic acid. Whenever you're finished with everything, discard it in your rinse beaker and dispose in the non-halogenated waste container, which is under the fume hood. So thank you for watching this video, and I really hope that it helps you in your lab experiment. Have fun, be patient, and learn.